we're ready now for Amides, section 21.7. So here's our primary functional group that we're interested in this section, the amide functional group. Remember, the amide bond is also called a peptide bond in biology and biochemistry and things. Now, what I want to take for a mechanism here is the mechanism of hydrolysis with a base. So we take an amide, and we're going to treat it with hydroxide. Okay? So when the nucleophile attacks the electrophile, are you recognizing those now more quickly? Again, this is a reversible process. We produce what kind of intermediate? Yeah, the good old tetrahedral intermediate. Okay? We're going to see these over and over and over again. Now, this is, of course, in water. This intermediate is hydrogen bonded to all the water around it. So there's a water molecule here, HOH, almost certainly been some hydrogen bonding to that lone pair that was on the nitrogen. And we're going to come down. Now we can go back and kick out the hydroxide, okay? But if the molecular vibrations are all right when we come down, we're going to kick out the hydroxide, not the hydroxide, hydroxide goes back. Let me cut that out. So when the lone pairs from oxygen swing down, we can kick out the amine. Now we can conceptualize this as an nitrogen anion and amide. Anion, that of course would then instantaneously pick up the proton and produce the amine and the carboxylate. And of course we had a sodium ion up here. We're using sodium hydroxide. That would be there for that. Okay. So again, the fundamental mechanism, knowing where things are reversible, recognizing and being able to draw the tetrahedral intermediate and have command of the leaving groups of that tetrahedral intermediate are very important for this chemistry. All right, so then we come to an amide. Let's look now at the chemistry of an amide. What we'll see is that, again, we don't make anhydrides, we don't make alcohols, we don't react with alcohols to make esters. We don't react with amines to exchange them. Although in principle it could be done, you're going to get nasty equilibria. It is very nice to do the reduction, and notice that we do not break the bond between the carbonyl carbon and the amine. Now this is different than the reduction of esters. Make sure you get that mechanism for esters and understand the difference. This remains intact, and the two blue hydrogens here come from the lithium aluminum hydride, and the pink hydrogen here comes from the aqueous workup. Okay. We can get reaction with Grignards as well, but we're not going to discuss that in this text. So let me take that out. And we're not going to worry about that in this section for us. All right, so that's the chemistry of amides. And that really concludes the chemistry new chemistry that I want you to learn in chapter 21.